Good morning, all. I'm Mrs. G. Ramani, Assistant Professor, Computer Science of Engineering from B.V. Raju Institute of Technology, Narsapur. And today we'll be discussing on the course Machine Learning. And the topic title is Data Preprocessing. This data preprocessing concept is of Unit 2. That is the title, Know the Data and Data Preprocessing. And the course objective of this Unit 2 is Understand the concepts of data preprocessing. Now, coming to the data preprocessing, we'll just discuss about the main purpose of data preprocessing. The main purpose of data preprocessing is to maintain the data quality or to check the data quality. And to check the data quality, we have few measures. And the measures are as the accuracy, completeness, consistency, timelines, believability, and interpretability. And to define the accuracy of a particular data, we have to check that whether the data is correct or wrong. And coming to the completeness, whatever the data we are working with, whether it is recorded fully or not, then only we can say that the data is complete. And consistency, whenever data has to be modified, we have to modify it completely. Then we can say that the data is consistency or it is maintaining consistency. And timelines, the data has to be updated now and then, timely. And believability, the data, whatever from wherever source we are taking from, it should be trustable. And interpretability, we have to understand the data properly. All these things are few measures to measure the data quality. Now, we'll just discuss about the major task of data preprocessing. We do have different tasks for data preprocessing. They are data cleaning, where we can say that the main purpose of data cleaning is to remove the irrelevant data from the data set. Because we cannot work with the whole data, or we cannot work or we cannot process the data with irrelevant data. So the data cleaning has its own profound influence on the data set. So we'll be working on missing values, we'll be working on noisy data, and we'll be removing the outliers or the irrelevant data which is not relevant for our particular task. And the next one is data integration. Data integration is one of the method of preprocessing where we integrate the data from different multiple sources. And the data representation might be of databases, data cubes, or the files. And the other one is data reduction. Data reduction, we are talking about the huge data. So that we cannot work or process the whole data as such. So the data has to be reduced into smaller sets where it will be easy for us to work on. And for that we have different methods. Those are dimensionality reduction, numericity reduction, and data compression. And we all know better that we'll be using data compression in our daily life. So the other one is data transformation and data discretization. That is, we all know that we are working with huge data. So the huge data has to be normalized. So normalization is a simple method where we use normally. So here in transformation and data discretization, we just use the labels for a particular intervals of period of time. And now we'll just discuss about each major task of data preprocessing. The first one is data cleaning. So in today's world, the data, whatever we get from different sources, is of incorrect data. We don't say that the data is accurate or the data is complete. The data is incorrect. And we are working with huge data sets. So we have to work on this incorrect data to get the relevant data for the process. And for that, the data may be incomplete. That is, we miss some of the values. There is a lack of some attribute values. Then we say that the data set is incomplete. For example, you just see occupation. Occupation is equal to, here we have some space. So what we say there, occupation is equal to space. So there is some missing, the value is missing over there. The occupation should be something like the student or any employee or whatever it might be. We have to fill that occupation value. We cannot leave that as such. So that is one of the incorrect data where we cannot work further. And the next one is noisy data. How to work with noisy data? Noisy data can be defined as some errors or some outliers. So how to work with this noisy data? So for example, we can define the noisy data as salary is equal to -10. Can we believe that salary can be of a -10? Yes, of course, it is an outlier. So what we have to do is we have to replace that particular salary with a particular basic statistical measures like mean, median, mode. And next one is inconsistent data. Inconsistent data can be defined as a variance, that is some discrepancies in some codes or in some names. For example, for a particular concept, initially we have rated it as 1, 2 and 3, and for the second time we have rated it as ABC. So there is a variation in rating. We have to use it as 1, 2, 3 or ABC, not a different 1, 2, 3 or ABC for the first time or for the second time. This is somewhat a variance or discrepancies in the names or some codes. So this is about the data cleaning methods where we can work on the incorrect data and for further process. Incomplete data can be seen, noisy data can be seen, and inconsistent data can be seen in the process of data cleaning. And the next one is noisy data. And the noisy data can be defined as some error or a variance in a particular data set. And now we'll just see how to handle this noisy data. And now we have different methods to handle this noisy data. They are binning, regression, and clustering. Coming to the binning, this is an example of a binning method. Now we'll just discuss about some steps for this binning. We have some 3 steps to remember easily. And the first one is, whatever the data set we have to sort, we have to sort the data into a decreasing or an increasing order. Increasing or an decreasing order, the first step. And the next one is, we have to partition it. We have to partition, right? Partition into equal levels of buckets or equal levels of bins. Equal levels of bins. All the bins, like we can get 2, 3, 4. How many bins you will be getting equal length? You have to partition the data. And the next one is smooth it. Smooth it in the sense, how we'll smooth it? With the help of basic statistical measures like mean, median, or simply boundaries. Simply boundaries. So what are the steps we have for binning? First, we have to sort the data set, increasing or decreasing order. Mostly we'll be going for increasing order. Next one is partition it, and the other one is smooth it with the help of mean or boundary. So here we have a simple example. I have some example of numerical methods like 4, 8, 15, 23, 21, 24, 25, 28, 34. These are the different numerical numbers what I have. So what did we do here? We have here 3 different bins, equal proportion. We have partitioned the numerical numbers into different bins, bin 1, bin 2 and bin 3. For the bin 1, what I have 4, 8, 15. For bin 2, I have 21, 21, 24. For bin 3, I have 25, 28 and 34. And the second step is smoothing. So we can use here the means. If you go for the mean, we'll be getting 9. So I'm smoothing all the numerical numbers with the mean value as 9. And for the bin 2, the mean value is 22. So I'm just smoothing to make the process easier. Wherever it is necessary, we can use this binning. We cannot use this binning for all the problems. So wherever it is necessary, we'll be using. And so this, if you want to use the statistical measure mean, you can go with the mean. Or simply, if you want to go for the boundary, you can go with the boundary. You just see over here, the third one. Here I have used 4 and 15 as the boundaries. Why 4 and 15 is? For the 4 and for the 8, the 4 is the nearer one. So I'm smoothing it with the help of the boundary 4, and the other one is 15. So the 15 will be as such. The boundary is 15, so I'll be using as 15. So for the second one, it is 21, 21, 24. So 21 and 24 will be the boundary. And for the bin 3, I have 25, 28 and 34. So the boundaries will be 25 and 34, minimum boundary and the maximum boundary. So whichever the value is nearer to the minimum boundary, you have to check it out, and the value which is nearer to the maximum boundary, you have to check it out, and you have to place or the smooth the values, whatever you have. So hope these are the 3 steps which are easy to remember when we are working with binning. And the next one is the regression. Regression is one of the most powerful method where we use normally. So here regression will be mostly using with the help of a particular function. We all know the function y is equal to mc plus. Okay, so we just have a particular regression function. So where this regression function, we will be getting a particular line from here, where we'll be getting a straight line, where it is used to distinguish between the different data sets. And when we use this regression line, it is distinguishing the 2 data sets. That is, we are getting 2 different classes. This, can you see here, these are the data sets which are below the line, and these are the data sets which are above the line. These are the data points below the line of this regression function, and these are the data points which are above the line of the straight line. So where they are distinguishing, we are getting 2 different classes, where it is easy for us to work on which data set is relevant for your task. And this data set is irrelevant for this, and this class will be irrelevant for this class. So this is one of the regression concept where we use the data set which they fit on this straight line. And the next one is your clustering. Clustering is one of the important concepts again. Why? Because we do work with huge data sets where we don't find any class labels. So when we don't have any class labels for a particular data sets, we just use the method primarily, which is called as the clustering. Clustering, the main motto of this clustering is to remove outliers. But how? How it is removing the outliers is, see here, this is the image where we see all the data sets. All the data points have been scattered over here, and when after the clustering here in this graph, you just see here we have some 4 clusters, 1, 2, 3 and 4 different clusters we are getting. How we are getting these clusters is, in this clustering method, we just group the data points which are similar to each other, but similarity. So how we are working with this similarity is more important. The simple thing is the distance. We can use a number of distance measures. One distance measure is Euclidean distance. Euclidean distance. Okay. So based on the similarity of the 2 data points, if the distance is lesser, they'll come into a particular class group. Based on the similarity, all the data points will be grouped into a particular class. So based from this data points, we are getting some 4 different clusters which are very much where they have more proximity. So cluster 1 will be irrelevant to cluster 2. So we have 4 different clusters over here. So to work with noisy data, we have the binning method, regression and clustering. Now we'll just see about the data integration. So we just don't work with only a single database. We'll be integrating the data from different multiple sources, from different data sources, and the representation of the data is also different. So data integration has a lot of influence when we are working with a particular database. So we can define the data integration as integrating or combining a data from different sources. And when during integration, we do come across few problems. The first one is data entity identification problem, because for the same entity, one of the database may use in a different form, the other database, the other source will be using or representing in a different form. So this entity identification problem is one of the simple and the frequently seen in the databases. For example, for a particular entity, for a same entity of the different databases, the values are represented in a different way. So, for the same entity, when the values are represented in a different way, it is not easy for us to process, to make a particular decision. For example, when we talk about money, when we talk about a particular money, the money can be represented in rupees or it can be represented in dollars. But the representation is different. So, for the same entity, money. So, we have to check such type of entities when we are working or when we are integrating from different sources into a particular database. And the next one is redundant data. During integration, redundancy is a common problem where we come across during integration. So this redundancy can be worked on with the help of object identification. Object identification, in the sense, for the same entity or for the same object, for the same entity or for the same object, we do have different names. We do have different names. For example, in a particular database, they'll be representing a customer as customer 1. And for the customer in the different database, they may be representing as a cust 1. So, customer 1 is a different name, cust 1 is a different name, but both are talking or they are representing of the same entity, customer. For the same entity, customer. So this object identification is one of the frequently seen simple method where we have to check during the integration of a particular data set from one database to the other database. And the other one is derivable data. Derivable data is somewhat which is derived from one table to the other table. During that integration also, we have to check whether they are derived with the same name or with the same title or not. And this redundancy can be checked or can be overcome with the help of analysis which is called as correlation analysis. Why? Because by manually or by simply checking, we cannot say that this customer 1 is the same entity name of the cust 1. So we need some analysis to get to a particular conclusion whether this the customer 1 is equal to the cust 1. So that can be done with the help of correlation analysis. Correlation analysis can be used to correlate the two entities, and we have a particular formula for this correlation analysis that we go for the text chi-square test. This is chi-square test where we have a particular formula for this, that is observed minus expected whole square by expected value, okay, summation of. This is a formula what we use for this chi-square test. Chi-square test is one of the correlation analysis. If we get the chi-square test value is more, then the two entities whatever we are working on are related, that is positively correlated. If the chi-square test value is negative, then less or negative, then these two entities are negatively correlated. If the chi-square value is 0, then we just say that the two entities whatever we are talking about, the customer 1 or cust 1, are neutral. So this is about the correlation analysis and the chi-square test. And we do have a covariance analysis also where we work on. And now we'll just move to the data reduction, the next pre-processing method. And the data reduction is one of the method where we reduce the representation of the data into a smaller set. of the data, where we just go with the process easily and to produce the same output as with we work with the larger data sets. So here the main purpose of the data set is to work on the complex data analysis to take a very less time to run on the reduced data set. So now we do have different methods for this data reduction. They are the dimensionality reduction and the numericity reduction. Under the dimensionality reduction, we have again the different methods: wavelet transform, PCA, and the feature subset selection. And we do have this PCA, and where we discuss this in our next video. And coming to the numericity reduction, we have regression, histogram, clustering, sampling, and data cube aggregation. And this regression we have already discussed in the concept called as the noisy data, handling the noisy data. We have discussed about the regression. And coming to the histograms, histograms are also concepts where we just transfer the data set into a particular categorical data. For example, you just see here, we have grades over here. For example, when we take the grades, we do categorize the grades into 6. The people who got CGPA as 6, 7, 8, 9, and 10. Now here we have different categories where we can work on particular assignments, some work, some or activity to be given to the different category students. So this type of data sets where you need a particular category for a particular data set, then you can go with the histograms. That is where you have a equal or a intervals for a particular continuous data based on a particular categories or based on a particular some interval scale. And the next one is your clustering, and the clustering is also discussed before. And then the other one is the sampling. From a particular, we can define sampling as from the whole data sets, we do take a smaller set of data set and we work on a particular sample data set to get a particular output. So we do have different types of samplings, and one is sampling with replacement, and the other one is sample without replacement. That is, from the whole population, we are taking some of the data set, some subset we are taking as a sample and we are working on. That is, we are replacing, working with the subset, we are replacing into the population. That is called as sample with replacement. And the other thing we have is sample without replacement. We are taking the sample data from the whole population, but we are not replacing into the population again. And we do have the other methods also. For this sampling method, we do discuss. And this is about the data reduction, and the course outcome of this data preprocessing is applying the data preprocessing techniques and prepare the data ready for the analysis. And in the next video, we'll be discussing on data reduction, different methods of data reduction. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.